So the underlying concept in this question is that if you have a number that has this prime factorization, meaning some prime number to the power of a1, a2, so this is a general representation, then the total number of factors, inclusive of 1 and the number itself, is just whatever these powers are. You add 1 to it and keep multiplying. So I won't go over where that comes from, but that's an important result. Now, we're told that in this case, the outcome is 4. So what are the different ways I can get that? Well, if a1 was 3, meaning you just had n has this form, some prime number to the third power. For example, if the p itself was 2, then that number is 8. And if you list out the factors of 8, they are 1, 2, 4, and 8. As you will see, is exactly 4. So this is one type of a number that would satisfy this condition, and we can immediately write the ones that are less than 50. One is 2 cubed, which is 8, and then 3 cubed, which is 27, and you'll see 4 cubed is 64, so that goes beyond 50. So we have 2 such numbers so far. Now there's another way this can happen, that 4 is a result of 2 times 2, which means that a1 is 1, a2 is 1, which means it's product of just 2 prime numbers. An example would be 3 times 5, 15, and the factors are 1, 3, 5, and 15. So we need numbers that have this form, and the result, meaning the product of those 2 primes, has to be, of course, less than 50. So if the first one is 2, then what are my choices for the second one? So I'll just write down the first few prime numbers: 7, 11, 13, 17, 19, 23, and then 29. And we'll pair the 2 with these numbers. 4. So all of these will have exactly 4 factors. Not this 29, because 29 times 2 is 58. So for example, if I'm considering this case 2 times 13, which is 26, I will have 4 factors: 1, 2, 13, and 26. And same is the case of 2 being paired with these other primes. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 more. So we had 2 here, 8 more. And then we can start with 3 and pair it with 3 with 5, 3 with 7, 3 with 11, 3 with 13, and 3 with 17 won't work because that's 51. So we get 4 more. And then next we move to 5. 5 times 7 is 35. It is indeed less than 50, but 5 times 11 is 55. And so we have just 1 more, because if we now go to 7 and 11, that's 77. So the reason I'm doing it in this general way is that they could have changed it to 100, which would make this question harder, and you would have to count more of these products. But that's the total number that we need, which is, if I add them, I get 15 such positive integers. If you have to list them, I would say 8, 27, and then 2 times 3 is 6, 10, 14. I hope you see where this is going. And again, whatever the numbers result here. So to summarize, the answer is 15.